Happy New Year. The title of our paper is Technology Aided and Practical Oriented Innovative Trends in Engineering Education. Today I am supposed to present before you the efforts taken by me as Principal of Atharva College of Engineering, Mumbai, and as HOD of its Electrical Department. IUCEE started its workshops for improvements in teaching and learning process and proper subject teaching methods back in 2007. Whatever was taught in the workshop at Infosys Training Center was imparted to the teachers of Atharva in a faculty meeting, giving a complete substance of the workshop. IUCEE started with other tracks in due course of time. I, as principal and an experienced teacher in engineering colleges, was trying to enforce various policies since 2007, and my success story started with the development of Entrepreneurship Cell. My efforts to nurture technical aptitude and entrepreneurship spirit among the students started showing results since 2009, well rewarded by any organization from time to time. Atharva was not very well organized when I joined, but with the help of HODs and faculties, I could start many systematic steps like course file making with detailed list of points to be prepared in advance to improve teaching learning process, mini projects per subject, question banks for students' preparation, compulsory 2 tests every semester, and marks to be averaged considering both the tests, preparation for NBA accreditation, making proposals to the management for gaining adequate points as per NBA form, faculty meetings every Friday to solve their difficulties, conducting one T&P class every week for second and third year students, initiating industry institute interaction, started E-Yantra robotics activities, EESA Electrical Engineering Students Association, Ember eCell, etc. The response was not fully satisfactory, and hence I decided to take pinpointed efforts when I became the HOD and directly measure its results in the form of this paper. The Indian engineering colleges started facing the pressure of competing with foreign engineering colleges and gradually adopted new techniques. I can continue my services as a professor and ensure all the changes at the root level in my subjects to encourage active learning right from the first year. At the outset, I have to acknowledge my colleagues and students because without their cooperation, this paper would not have been possible at all. The students of our first batch of electrical engineering definitely developed a thought process based on knowledge and technical skills. This was passed on by them to their juniors by conducting various workshops, example, electrical wiring and maintenance workshop, AutoCAD training workshop, etc. The same spirit is being inculcated in their juniors also. The purpose has started to serve. The electrical students have developed self-directed learning to apply their knowledge, ideas, and efforts in finding innovative projects and their implementation. The process has just begun. It will take a few more years to get fully established in terms of excellent academic practices. So let us see the slides showing our efforts. The activities mostly speak about academic years 2013-14 and 2014-15. Our paper elaborates the initiatives taken by the department to improve teaching and learning process by various methods, use of teaching aids, emphasis on practical training, and application-oriented activities to take the department to higher levels. To enumerate the novel efforts taken by the department, we concentrated on innovation in teaching learning process, Electrical Engineering Students Association to be run by them under a teacher's guidance called EESA. Interaction with employers. We even conducted a seminar by inviting representatives of 9 companies to give the students a glimpse of industry environment. Training and placement activities. Special T&P sessions were arranged for providing training in various programming languages and to improve their skill sets. At college levels, the activities of EESL, EENTRO and IEDC were initiated and governed under my guidance. So, coming to the first point of innovation in teaching learning process, following modifications are incorporated. Innovation in teaching, mentoring and counseling students, writing of assignments in lab periods, presentation by students. Latest innovations in various subjects were discussed for few minutes in lectures. The practice was followed by every teacher for her subject once in every week so as to increase the enthusiasm of the students knowing achievements in that subject. Latest developments followed by discussion of new applications for respective subject encouraged interactive sessions. Examples include solar concentrators, distributed generation, hybrid systems, fuel cells, nanotechnology, seasonal and critical loads, latest application of power devices, etc. It is felt that with this effort, students realized the need for having depth in interdisciplinary engineering knowledge. Mentoring and counseling students. We took efforts while making the timetable to keep dedicated slots for mentoring, counseling, T&P training in addition to regular practical sessions. During mentoring, students were asked to regularly attend lectures and labs, and their personal and financial problems were discussed and resolved, which has shown a little improvement in their attendance. Discussion was made particularly with defaulter students. During counseling sessions, subject-related doubts were solved along with career guidance and entrance exam preparations, which did help the students. Guidance was given in practical implementation. Example, in MATLAB coding and simulation, in many projects, for example, microcontroller-based ceiling fan control, interfacing and testing, project report preparation, etc. This turned out to be more effective due to small batches of students approaching teacher in a fixed slot every week. Every college must be following similar practices, but our practice got augmented because of availability of fixed time slots every week. Students could plan their queries in advance. One student's doubt helped all other students to clear their concepts. Writing of assignments in lab periods. Every semester, as per university norms, students are expected to write minimum 2 assignments per subject. In general, the students used to copy the assignments just a few days before the time of submission. Thus, the purpose and habit of regular study was not achieved. Therefore, it was very necessary to remove this conventional paper filing practice. Hence, we used to give 2 questions per week in advance. Students are supposed to study the ideal answers at home for each subject and write it as a test at the start of respective subject practical, say for 30 minutes. Thus, students practiced remembering and understanding of a part of syllabus with ideal answers prepared in advance as a mini preparation for final exam. Presentation by students. We also used to tell them in a group of 4-5 students to prepare a PPT on an already taught particular topic so that they understand the topic thoroughly. It was expected that they make the PPT to make their fellow students understand the matter in a better way. Then it is corrected by teacher for perfectness. Thus teaching becomes more fruitful and enjoyable by students. It is expected that students gained more depth of understanding for a part of syllabus and learned to enjoy the subject. Coming to the second novel point of our efforts, this is to mention that our management has provided a virtual classroom capable of transmitting and receiving high-definition video classes using Polycam and Skype. We could arrange at least one lecture for each subject per semester by eminent people. The facilities covered virtual lectures, NPTEL video lectures, Moodle, WICSET, and webinars. Virtual lectures. These are generally kept for 1 or 2 hours depending upon the topic and availability of the expert. The last semester topics included Control System Modeling, State Space Approach by Dr. Prasiddha Trivedi, IIT Bombay, Cyclo and Matrix Converters, Mr. Nimish Soni, Bosch Engineering and Business Solutions Limited, lecture on latex, etc. Students could get a feel of advancement in their subject knowledge from an expert in that field. NPTEL lectures. The same facility could be used to relay NPTEL video lectures from faculties of IISc Bangalore, IIT Bombay, IIT Madras, etc. Teachers studied the topic in advance and explained in between, inviting interaction of students. Examples include multi-level inverter, pulse width modulation for power electronic converters, digital system design, power system dynamics, two-port networks with distributed and lump parameters, etc. Students learn the depth of analysis required in understanding a subject. Moodle. Use of Moodle is very much justified as everything including syllabus, question banks, university questions, assignment questions, innovations discussed in class, PPTs, notes, lab manuals were uploaded on it, and paperwork was reduced. Every student could receive it without fail, as everybody's name is registered under Moodle. Soon we are going to make it open for 24 hours so that students' convenience is further increased. Students had an advantage of using a modern tool. WICSET. WICSET is an improved version of Moodle. Use of WICSET further enabled the students to appear for online tests, quizzes, create learning group of students and join for discussions, upload technical videos, example on robots, latest articles in magazines, then answer solutions to students' doubts by teachers and seniors, and create their profile on this networking website as it is available for all the time. Students got use of modern tool for placement purpose, the whole sole objective of becoming an engineer. Webinars. Updates of webinars are uploaded on Moodle and teachers and students can listen to them as per their interests. For example, webinar by Virtual Academy. Topic being, are students motivated to learn? A diagnostic approach to academic motivation and engagement, and of course many IUCEE webinars. The practice enabled students to get a realization of becoming a capable global engineer. Coming to the third point of our efforts, practical training included simulation of experiments, mini projects for each subject, virtual lab. Mini projects for each subject were planned for each group. Advantage of virtual labs at Tier 1 institutes was also taken. The effort to ensure small practical batches was fruitful. Our class strength is generally of 80 students and we divided them into 4 instead of 3 batches. The students per batch were only 20 and hence per group or per experiment maximum 4. Coming to simulation of experiments, we decided to give emphasis on simulation of experiments before actually doing the experiment so that they can play with the simulated circuit diagram by varying the values of various parameters and then do the actual experiment with full depth about the expected results. The students were given training for using MATLAB Simulink so that they can design the circuit giving optimum results and learn to interpret the results properly. MATLAB was used for design and simulation of control rectifiers, buck-boost converters, inverters, HVDC link, hybrid systems, etc. Students were also encouraged to learn PSpice, which was more suitable for power electronics, and Scilab, suitable for signal processing and statistical analysis. Students got a glimpse of attempting problems analysis in this exercise. Mini projects. The purpose of developing conceptual learning through mini projects was well tried. We insisted for making the student groups to select a topic in which the basics can be understood better by doing an experiment as a mini project for each subject. Necessary help was given to each group for referring and deciding suitable projects. If in some subjects actual experiment was not possible, they were asked to prepare a poster collecting relevant information either at national level or at global level. The examples of mini project includes characteristics of devices, charging and discharging of capacitor, use of nanotechnology, innovative smart cards, and electromagnetism, etc. They were also made to write a report giving literature survey, block diagram, circuit designing, problems faced and action taken, simulation results if essential before actual implementation, hardware implementation, graphs, verification of results, cost of the project, etc. Shortlisted groups compete in TechFest and EESA. Students attempted design and development of solution along with team building and management. Virtual labs. In using virtual labs, students read instructions, available list of experiments, its theory, download prerequisite software, understand animated demonstrations, and perform various experiments. Examples include VI characteristics of MOSFET at IIT Guwahati, diode as half-wave rectifier at IIT Kharagpur, implementing logic gates in PLC at IIT Bombay, as well as study hardware and software used in PLC. Students could work on highly developed laboratories in Tier 1 colleges. Coming to the last point of our efforts, it included EESA activities, workshop committee, Ember eCell, eYantra robotics, IEDC projects, TNP classes, etc. Electrical Engineering Students Association as one of the EESA activities, the various competitions conducted are poster presentation competition. We make the students to work on general topics such as electrical power supply position in India, renewable sources and their implementation, details of power plants in India, etc. Students demonstrated self-made working projects to the external judges. For example, solar cell phone charger, RFID-based home automation system, mobile detector, etc. In just a minute competition, chits with technical topics were prepared and every student picked up one chit on the spot and spoke for 1 minute. Students of higher class planned and prepared for technical quiz competition in consultation with the teachers and conducted it for the remaining students. Students enjoyed the feeling of independently managing the competitions, functioning effectively as an individual as well as a member or leader in diverse teams. In addition, students exhibited technical capabilities for implementing mini projects and designing the technical quiz. EESA workshop activities. The various workshops conducted by the students under EESA activities are workshop on AutoCAD training, electrical wiring and maintenance workshop, latex workshop by faculty, and expert lecture on GD and PI by Time Institute. Workshop on AutoCAD training included basic drawing shapes such as triangle, circle, and polygons, scaling, mirror image, chamfering and fillers in 2D, transforming 2D drawings into 3D, 3D isometric drawings, etc. Students enjoyed the pleasure of delivering and managing their own technical workshop and exhibiting their communication skills. Electrical wiring and maintenance workshop. Students having a better knowledge themselves planned and conducted this workshop for various aspects of wiring for other classmates and junior students. Figure demonstrates series and parallel connection showing effects of different wiring schemes on bulb intensity. Students were also given hands-on practice on house wiring so that they can handle minor repairs. Figure demonstrates house wiring method and use of fuses as a safety measure. The electrical gadget chosen was electric iron, and the construction of electric iron consisting of bimetallic strip and thermostat was demonstrated. This picture demonstrates construction and function of choke and starter and causes of faults in tube light by block diagram and actual experiment. The pictures are shown so as to confirm that students themselves managed it. Students brought a used ceiling fan holder and demonstrated its construction and working, as well as fan regulator, fault detection, and measures necessary to overcome the fault. Thus, students understood the need of their friends and arranged engineering services by conducting various professional workshops. In latex workshop, students were exposed to technical report writing using latex by our department faculty. The intention was to make them write mini project reports in latex. The electrical engineering department also organized one-day workshop on renewable technologies for electricity generation. The topics covered were wind turbines, types, construction, working, failures, and applications. Load calculation and cost estimation, entailing 1 megawatt grid connected solar PV power plant, load requirement, space constraints, and payback period calculation. Concentrating solar power, solar energy solutions. Students could learn basics, terms involved, and technology used in solar PV power plant installation. For example, project planning and scheduling, design and engineering, installation and testing, civil activity, government incentives, etc. They also learned concentrating solar power using Scheffler's parabolic dish, parabolic trough collector, system modeling, solar energy solutions. They also learned wind power potential, construction, working, failures, components and specifications, ratings, sites, power generation, efficiency, etc. Ember E-Cell started in the year 2007 and Atharva won its first Innovation and Creativity Award and Honor Roll Award in 2009. Students of first year built a windmill on the terrace of our college. The enthusiasm for conducting various activities during E-Week was enormous. E-Cell won the same awards in 2010 and 2012 also. Atharva E-Cell won Champion Runners-Up Award in National Level Entrepreneurship Week 2013 and 14 conducted by NEN. Atharva became famous for starting various campus ventures such as supply of calculators and drawing equipments for first-year students, soldering iron kits, lab coats, lunch tiffin of good quality, etc. Two students even successfully managed a startup called Wintech. They also learned social entrepreneurship by helping the underprivileged through its program, serving economically weaker alike, known as Seva. They visited the famous place of Anna Hazare, Raleganj Siddhi, and prepared a model in the college during E-Week to demonstrate the innovations found there. Thus, students learned entrepreneurship on a mini scale. E-Yantra Robotics was the initiative of IIT Bombay, and our college was one of the first 15 colleges to become a center for E-Yantra Robotics. This program was sponsored by MHRD to IIT Bombay, and it started in Atharva in 2012. Students learned about robotics, microcontroller programming, and interfacing using the E-Yantra robots for various tasks of line tracking. They can also use these robots for embedded system projects for final year. Students had to apply their knowledge to make the robot complete its task. The knowledge of this scheme of DST, Department of Science and Technology, was given in one of the workshops conducted by NEN. We applied taking guidance of NEN and succeeded to get funded by DST for 5 years. The main aim of IEDC is to motivate the students to develop community-based projects for innovative products for society welfare and become an entrepreneur. Students had to investigate a societal problem, search a solution for the same, and make a good presentation to earn the funding. As a result, Atharva got a funding of rupees 13.3 lakh from DST department in the year 2012-13, 8 lakh rupees in the year 14-15 as per the scheme. The projects contributed by electrical department in the year 2014-15 were grid inverter and smart floor cleaner. Funding yet to be received for following projects for the academic year 2015-16 from electrical department: automated farming system with pilot irrigator, solar-based hybrid irrigation system, fire extinguisher using sound waves. Training and placement activities. The main intention was, of course, to make the students ready for campus interviews. Out of 4 batches for practical session, 1 batch was always given TNP training for 2 hours every week. The training included subject basis, qualitative and quantitative aptitude, logical reasoning, general knowledge, math including calculus, probability, permutation and combination, etc. Students develop the right mindset for preparing for the placement. As a part of TNP activity, we uploaded 1000 aptitude papers on Moodle for students to appear for the online test series. Extra TNP lecture on C, C++, Java, GD and PI were conducted. Students attended IIT Bombay spoken tutorial and also gave online C test. Number of students appeared for online C test were 63 and 37 cleared it. Qualified students got an e-certificate from IIT Bombay on completion of the test. Detailed results of students for online test for spoken tutorial from IIT Bombay is shown. Total students appeared were 63 and the result is clear from the bar chart. Results of TNP activities in our college was very good. Following top 5 companies agreed to come for placements in Atharva: Infosys on 1st and 2nd October, Accenture 5th and 6th October, Tech Mahindra, iGet and L&T in subsequent weeks. Department organized an industry meet for increasing students' awareness about working of electrical industries and enabling them to choose the right career. We succeeded in getting all core electrical companies. The names of invited companies and their specialization are shown in the table. APJ Enterprises specialized in diesel generator sets. Power System Consultants dealing with electrical system design, testing and commissioning. Siemens Limited, automation and drives. Larsen and Toubro Limited, Crompton Greaves. Aeron Corporation India Private Limited, dealing with control panels. Europower, leading manufacturer of power components, power amplifiers, inverters, etc. and so on. The various speakers from different industries had brought their PowerPoint presentations, giving full idea of their activities and videos demonstrating various processes. Their common expectations regarding career and opportunities in industries where students should be disciplined, punctual, they should have passion for the technology, ready to work hard, they must have quality of self-learning, research-oriented thought process, etc. Students should have a good understanding of the basic concepts in every subject. Some industries motivated students to become entrepreneurs by making such B projects which can be further transformed into business or some venture. Some asked students to think innovative and convert their passion into vision and vision into action. Some guided students to study abroad and do some work on company-sponsored projects. The students were very delighted to get the feel of an industry through various videos. They got a true picture of industry atmosphere. They were even promised the internship in summer holidays, but this needs to be thrashed out at higher level to establish a memorandum of understanding between colleges and industries to ensure a regular practice of training the students for practical knowledge. Now we have to assess the results of our efforts. We provided various ways for taking the feedback of students, such as online feedback, suggestion box, feedback from form distributed in the class. However, students having 65% above attendance in lectures were only allowed to participate in feedback activities so that their feedback is not fake. A suggestion box was also kept in every classroom at times and collected their anonymous feedback. When these chits are read, at least by HOD and class in charge teacher, every possible suggestion worth considering was noted for further action, thus ensuring further improvement. The exercise should enable the students to exhibit responsible and constructive approach in delivering their feedback. Students' feedback results for our initiatives to verify the outcome. Figure demonstrates results of feedback activities for innovations in teaching and teaching aids as per the grading provided. The points are interactive lecture with question and answer session, writing of assignments as a test, mentoring and counseling, virtual classes, NPTEL lectures. The adopted grading system clearly shows that we have to still improvise utility of virtual class and NPTEL lectures. Feedback results for practical and placement initiatives. Mini projects, simulation using MATLAB, simulation using PSpice and PLC, TNP classes, preparation for GATE exam. The feedback is best for TNP initiative and other feedbacks are also very satisfactory. The efforts need to be more consistent. Feedback results for EESA activities: just a minute competition, workshop on AutoCAD and LaTeX, workshop on home wiring, maintenance and safety measures, e-Yantra robotics, entrepreneurship activities, and industry internship. The overall result is good, though we have to take further efforts to reach excellence. Currently, students' interest in robotics is highest. Our first batch of EE department itself happened to be very good. The result shows number of students passing without KTs. So it has definitely shown improvement up to 4th semester and a little downfall in 5th and 6th semester. Our first batch was in 7th semester while submitting this paper. Hence, we could plot the results for second year as well as third year. The bar graph shows improvement in marks obtained by final year EE students from SE to TE. The bar graph for KT results in each semester clearly shows success of our initiatives. The distinction number is large in semester 3 and 6 as against semester 4 and 5. The number of first class students is very high in 6th semester compared to all other semesters. Effectively, the second class number and particularly KT students have decreased remarkably. Our department took efforts to build up a right culture to nurture practical engineers and not just bookworms right from the first batch. They have actively participated in all co-curricular and extracurricular activities of college and came out with flying colors. Of course, they have learned planning, implementation, and dedication essential for becoming an engineer. Thus, it is felt that we made a good effort to achieve the engineering attributes such as depth of knowledge, problem analysis, design development of solution, modern tool usage, engineer and society involvement, individual and teamwork. Our special thanks to Shri Sunil Rani Sir, Executive President, Atharva Group of Institutes, for giving all kind of encouragement for the right cause. As a new initiative, he sanctioned following projects for electrical department and SE electrical students are working on it. Removal of milk adulteration, making helicopters using scooter engine, avoidance of train collision, use of carbon from the atmosphere as ink for printer, wireless remote control without battery. Thanks to all our students of electrical department for their active support for implementing above changes and realizing its effects. These are the references. Having experience of my own engineering career and shortcomings faced, I have tried to overcome those drawbacks as much as possible. It takes a lot of time to implement the changes fully and simultaneously satisfying the norms of university affiliation. The syllabus is quite vast, along with so many activities, and the available time in each semester is not sufficient. It needs to be designed optimally, keeping good amount of stress on practical work. In Vancouver, I came to know for the first time that even first-year engineering students are expected to do projects, and one of the projects was to design a kitchen for blind people. Indian teachers themselves are not trained in such a direction, and they have to put in more efforts for achieving the results. There are too many activities going on in the college attracting the students, and concentrated efforts in a particular direction cannot be ensured. Hence, it is necessary that the program designed is itself so well formulated that automatically the graduate attributes are achieved. For example, I used to insist for many projects despite of tremendous opposition, but when it was gradually included in the university syllabus, there was absolutely no problem for its implementation. In order that students understand the meaningful aspect of engineering profession, we celebrated Engineers Day on 15th September, focused on Sir Visvesvaraya's achievements as an engineer and also the activities accomplished by him for the welfare of the society. Engineering must be carried out with full responsibility in an ethical manner, which we try to emphasize through our own behavior, teachings, and practices. Further, I had taken my ESL students almost every year to Pabal, knowing Mr. Ashok Kalbag, as the practices followed there should be experienced by every student to learn the meaning of engineering in real sense. Thus, it is expected that the program designed for any discipline should incorporate such engineering activities which will enable students to play roles of an engineer, engineering technologist, and engineering technician as well. The fundamental purpose of engineering education is to build in the first stage a knowledge base that will enable them to develop the competencies required for independent practice. The second stage, after a period of formative development, is professional registration. Once registered, the practitioner must maintain and expand competence. Is there any such process defined for Indian engineering graduates? For engineers and engineering technologists, a third milestone is to qualify for the international registration held by various jurisdictions. In addition, engineers, technologists, and technicians are expected to maintain and enhance competency throughout their working lives. Hence, the authorities are expected to design a program that builds this type of knowledge and develop the attributes to give confidence to the society that the educational objectives of the program are being achieved. The quality of a program depends not only on the stated objectives but also on the program design, resources committed to the program, teaching and learning process, and most important is assessment of students to provide confirmation that the graduate attributes are satisfied. In my opinion, this further connects to the need of a technical university with academic experts and highly experienced field professionals fully entrusted only with the assignment of improving engineering programs to fulfill the requirement of global engineers. With this, I propose to end my presentation and I am open to any questions now. Yes, Mr. Sridhar, anybody asking question? Hello?
Hello.
Yeah.
Do you think that the course lectures delivered by industry experts with examples of products and system development coupled with practical field application help students at Atharva?
Yeah, first of all, they got a real view of what is happening in industry. Moreover, they could discuss their difficulties with those people because they were available for the whole day. And they also offered internship. They uh, also gave them guidance how to apply for their industry, what they expect from the engineering students to give them appointments. And this way I feel that they were benefited. Anything else I did not refer to in the question?
One other participant asked, what is the duration of the mini project?
Duration of mini project, it is expected that within first 3 weeks, everything should be finalized. Next 3 weeks, everything should be completed, because they can work only once a week on the mini project or whenever they get a free period or sometimes in the practical period, and they should be able to submit it before the final submission starts.
One of the participants says, "Thank you very much for the nice presentation and good work done by your team of faculty members and students."
Thank you. Thank you so much.
The person who asked the first question is saying that reference was to course lectures delivered by industry expert.
Yeah, industry experts, that Bosch Engineering, Nimish Soni, he was an industry expert only.
Were the topics for projects proposed by faculty or students will pick up the projects?
We give them guidance for referring various magazines and these things, and they come with the topics. Then we discuss and we finalize with the guidance of the teachers. But they are made to work on it. That is definitely first. Before just like that, the guidance is not given.
It was a very good initiative and implementation by the team of Atharva under the guidance of head. Important is students also responded and acted well.
Yeah, that is true. That is true. The way students have given the feedback, I was telling them, I hope you are giving the feedback, real feedback. And then they said, yeah, of course. What do you mean? Because I wanted to ensure, that what we are doing is in the right direction. It is liked by the students also. Otherwise, it will be not useful.
Would Atharva be interested in lectures by industry experts in electrical engineering?
Very much interested. Anybody is there?
This is Mr. Anil Pandit. I will pass on your email ID to him.
Sure, please. We will be very much interested.
The attendees can type in their questions through the chat box. We still have a few more minutes.
Sure.
There seem to be no more questions. Thank you very much for the webinar.
Thank you so much for all the arrangements. Thank you.
Thank you.
Yeah.